Thank you very much for joining us and welcome to another fantastic lesson. In this tutorial, we are going to look at question number 16. This is a KCSE past paper question for the year 2011, paper 1, and it goes as follows. A small cone of height, 8 cm, is cut off from a bigger cone to leave a frustrum of height 16 centimeters. If the volume of the smaller cone is 160 cubic centimeters, find the volume of the frustrum. So, having read the question and understood it, we will come to note what it simply requires. So the first step 1, if I may say, is to sketch. Step 1 is to sketch. We have our sketch of the bigger cone. So the bigger cone, we are told that the height is 8 centimeters, whereas to leave a frustrum, so the bigger cone is this. So it is cut, we have the smaller cone, to leave a frustrum of height 16 centimeters. So this is the frustrum. This one will become our frustrum with height of 16 centimeters. We are also told that the volume of the smaller cone, this volume is equal to 160 cubic centimeters. So what do you note in this kind of question? There are several things I need you to see: bigger, smaller, height of the frustrum and height of the smaller cone, volume of the smaller cone, and the question now is find the volume of the frustrum. So this one will bring us to something we'll discuss, which we called the linear scale factor. There's something we talked about called the linear scale factor, area scale factor, and volume scale factor. We know that the linear scale factor for this case will be height of the bigger cone over height of the smaller cone. That is the first thing you do. And then we know that the relationship between linear scale factor and volume scale factor is given by, we say linear scale factor squared is equals to the area scale factor, and linear scale factor cubed is equal to volume scale factor. This is our point of interest. What we are doing is just for you to understand the bits that you're trying to bring up. So we'll find the linear scale factor. We'll find the linear scale factor. So first of all, let's look at the So let's find the height of the bigger cone. Height of bigger cone will be equal to height of smaller cone plus height of smaller cone plus height of frustrum, which is equal to 8 plus 16, which is equals to 24 centimeters. Therefore, we say now the linear scale factor, which is given by height of bigger cone over height of smaller cone will be given by 24 over 8, which is equals to 3. Remember, we've been given the volume of smaller cone to be 120 cubic centimeters. This from our statement here, 160 cubic centimeters. And you've been told to find the volume of the frustrum. Volume of frustrum is equal to volume of the bigger cone minus volume of the smaller cone. So we look for the volume of the bigger cone. So we say volume scale factor, which is given by volume of bigger cone over volume of smaller cone, is equal to linear scale factor cubed. So we have our linear scale factor is equals to 3. Therefore, we say 3 cubed is equals to volume of bigger cone over volume of smaller cone, which is given by 160 cubic centimeters. Therefore, volume of bigger cone will be equal to 160 times 3 cubed, which is the same as saying 160 times 3 times 3 times 3 is 27, to give me a volume of 160 times 27. This one will be 4,320. You can do it by the side here. 27, this is 12, 3. This is 42, carry 4, 7 plus 4, 11. This is 2, 3, 4, add a 0, 43, 20 cubic centimeters. Therefore, to find the volume of the frustrum, we have said here that volume of the frustrum will be equal to, volume of the frustrum is equal to volume of the bigger cone minus volume of the smaller cone, which will be equal to, now saying 4320 minus 160. That one will give us what? That is 0, 6. Here I'm remaining with the 2, 1, 4160 centimeter cube. This is the volume of frustrum. That is how we do it here. Thank you very much, and see you in our next tutorial, where we look at now question number 17. Thank you very much, and see you in our next tutorial.